All right, this is the linear motion homework problems. I know a lot of people put a pretty good attempt into them, but some of them were kind of difficult. So I want to make sure I walk through each one of them a little bit. So for PTC 24, what you've got is you've got a boat, can't swim ashore. I forget who the other one was. On a boat, and it's accelerating due to the wind at 0.29 meters per second squared for 18 seconds. I want to find the displacement. So there's a couple ways you could do that. You could simply use this formula, which I believe is the third of our kinematics formulas, although I think I numbered it number 4. Or we could use the area of the velocity time graph. So 47 meters. To find the area of the velocity time graph, I need to know the maximum velocity. So that's acceleration times time. It gives me 5.22 meters per second. So I put that up here. 1 half, 18 seconds, 5.22 gives me 47 meters also. So I won't do most of these that way, but I wanted to just let you know. For PC number 2, this is someone who's going this distance in a funny car, which is basically a drag car race. So they start from 0. It's taking them 4.43 seconds to get that distance. So the average speed is 90.6 meters per second. That's V average. That's not final velocity. To find the acceleration, there's a few methods. I'm going to use this one again. You really can't use acceleration as change in velocity over change in time with this value because that's an average speed, not a final speed. You would reach the average speed halfway through the time interval. So if you use that, you wouldn't be able to use your 4.437 seconds. You'd have to use something half as big, and most people won't think to do that. At any rate, I do have all the information for this again, so it comes up to about 41 meters per second squared. To find the final velocity of this, if I know that I'm accelerating at 40.9 meters per second squared every second, I'm doing that for 4.437 seconds, I'm going to reach 181 meters per second. For number 13, we were given a picture like this. You're asked to find the acceleration and then the distance traveled. So the acceleration is the slope of this graph. So final velocity is 0, initial velocity is 18, 0 minus 18. Final time is 6, initial time is 0, 6 minus 0. I get negative 3 meters per second squared. And again, it should make sense we have a negative acceleration because we've got a negative slope on our velocity time graph. And the slope of a velocity time graph is the acceleration of an object. To find out the distance traveled, I use the area of the graph. 1 half 18 times 6 is 54 meters. For number 18, we've got an airplane that needs to reach this takeoff speed. This is its rate of acceleration. I need to find out how far the plane, the length of runway to take off. I can use this mathematical model. That's what I get as my answer. Or I could use a graph, but a little more complicated. So I can figure out that it's going to take 14.7 seconds to take off because I can rearrange my A equals delta V over delta T. And then I can just use the area of this graph. 14.7 seconds, 28 meters per second. Again, 1 half base times height will give us that. Same answer, 206 meters. For number 20, we've got an initial velocity, a final velocity, and the time it takes to slow down. So the acceleration, final minus initial over time. So it's negative 18.8 meters per second squared. To find the distance traveled, I'd use this formula again. Vf squared equals Vi squared plus 2a. Should be probably a delta x, but that's okay. That's what I'm finding. And that's around 22.3 meters. PC 28, I think this is the hardest one visually, and I probably should have drawn a diagram here because I did it when I was thinking about it. You got the initial velocity of the camera is 10.4 meters per second. That's because it's falling at that rate before the person drops it. So then it's in free fall with that acceleration, and it falls this total distance. So I'm trying to find that final velocity. Again, I use this formula. Put delta y instead of delta x because it's vertical, but it doesn't matter that much. So we get around 33.6 meters per second. To find the time it takes to fall to the ground, I can use this. I could use another formula also. I think this is the easiest one. Here I know my change in velocity because I know my final and my initial velocity, and I know the acceleration due to gravity doesn't change on Earth, and so I can find the time interval, and that's around 2.37 seconds. For PC30, I'm looking at an object in free fall a certain distance, so again, it's just this. This is the rearranged version of the formula. You got to be really careful when you're squaring or square rooting something. And so that ends up being around 5.2 seconds. For part B for this, it's asking about the final velocity. So once again, I can use this last kinematics formula using delta y instead of delta x just because it's vertical. And I get around 50.9 meters per second. You could have also done v equals a times t. You know acceleration. You know the time. You could have gotten it that way. For number 8, I talked about this in class. I think I went over this in every class, but I'll talk about it again. The key thing here is thinking about the symmetry of this problem. Even though it only tells you that the time in the air is 3.56 seconds, that's given, this is all free information. Time up equals the time down, which is equal to half the total time if we land at the same height as it's thrown. The velocity at the top of the path is 0. The acceleration is down at all times, even at the tippy top. And so now what I can do is I can think about the second half of this equation, because I know that the velocity is 0 here. That makes my math a little easier. And that means my velocity is going to be down and my acceleration is going to be down. And that helps me because I don't have to deal with any negative numbers. All things are going the same direction, and I'll treat that direction as positive. So in that particular case, to find the final velocity, vi plus a times t, that t is half the total time. I should probably put that. T is equal to t 1/2. Oh, I already did that. Okay. And got that 17.4 meters per second. To find the maximum height, I can think about just falling, accelerating for that amount of time downwards. And that gives me 15.5 meters. So if I use the first half of the trip instead of the second to figure out velocity, that means I've got an initial 0 meters per second is my final velocity at the top. I've got an initial velocity up, but acceleration is pointing down. That's why that's a negative 9.8. And that's why in order to get that 17.4. So hopefully those help. Let me go here and quit this.